want to talk about ionic compounds and how to name these compounds. Ionic compounds are neutral compounds made up of positively charged ions, which are cations, and negatively charged ions, which are anions. So it's a metal coming together with a nonmetal. The metals are going to be the left side of the periodic table, and the nonmetals are going to be the right side of the periodic table. When we're talking about ionic compounds, the charge is important. So we have to be able to look at the periodic table and predict the charges of some of these elements. So if we take a look at the periodic table, we can assign charges to most of the elements. And in group 1 elements, they will have a charge of 1+. So all of the elements in group 1 will carry the charge of 1+. They're cations. All of the group 2 elements will carry the charge of 2+. The middle are called the transition metals, and they can have multiple charges, so we can't really assign those charges. Now, group 3 will have a 3+ charge. Group 4, we really can't predict their charges. Group 5 will be a 3- charge, and so if it's a negative, that would be considered an anion. Group 6 will have a 2- charge, and group 7 will have a 1- charge. We need to remember that when we're doing the formulas for ionic compounds. All right, let's see an example. Before we actually name compounds, ionic compounds, we need to learn how to write these formulas. So let's take a look at this example. We want to predict the charges for lithium and oxygen and then predict a formula. So let's take a look at the periodic table, and we see that lithium is in group 1. So that means lithium will have a +1 charge. Oxygen is in group 6. So that means oxygen will have a 2- charge. All I did right here is just predict the charges. For me to make a formula, I have to crisscross the charges and make them into subscripts. So if I bring the 2- down, it would be lithium 2, oxygen. I will bring down that 1+, and I put a 1. Now, the 1s are going to be invisible, so we actually write this as lithium 2, oxygen. We can't have any charges in our final answer because ionic compounds are neutral compounds made up of cations and anions. So our final answer for lithium and oxygen is going to be Li2O. Let's take a look at another example. Let's take a look at magnesium and oxygen. We have to find magnesium on the periodic table. Here's magnesium. So that means magnesium is in group 2, so it will have a 2+ charge. Oxygen is in group 6, so oxygen will have a 2- charge. When I crisscross the charges and make them as subscripts, I will get something like Mg2O2. Now, if we can reduce the subscripts, find a common number that we can divide all of the subscripts by, we should do that. So 2 can be reduced by 2, so my final answer will be Mg(O). That's my final answer for magnesium and oxygen. Let's take a look at aluminum and chlorine. We have to find aluminum on the periodic table. Aluminum is in group 3, so that means it carries a 3+ charge. Chlorine is in group 7, so that would be a Cl-. I'm going to crisscross the charges. So I'm going to get for my answer aluminum, the invisible 1, Cl3. Not only should we be able to predict the charges in the formula, but we should be able to go in the reverse. For example, if I gave you the formula AlCl3, you should be able to tell me that aluminum has a 3 plus charge and Cl has a 1 minus charge. If I give you the formula MgO, you should be able to tell me that magnesium is a 2 plus charge and oxygen is a 2 minus charge. So you should be able to crisscross the charges to make the formula, and you should be able to reverse the crisscross to make the cations and the anions. Now, this is how we write ionic formulas. Let's talk about how to name these ionic compounds. As always, when you're looking at a formula, you need to decide if this is ionic, and if it is ionic, then you can use the rules. We decide if something is an ionic compound if we have a metal and a nonmetal coming together. Also, if we have a metal and a polyatomic ion that comes together. The polyatomic ions are on this table here, and we should memorize this table. So these are one or two or more elements coming together to form an ion, a charged particle. So how do we name ionic compounds? We always name the cation first, that is the metal. Then we name the anion second, but we have to drop the ending of that element and add a new suffix, IDE. So we don't say oxygen, we say oxide. We don't say sulfur, we say sulfide. Okay? Now, the only hiccup is if the cation is a transition metal, then we have to use Roman numerals to indicate its charge. Let's take a look at the first example. We have magnesium and we have sulfur coming together to make a formula. First thing I want to examine, is this a metal and a non-metal coming together? It is. Mg is a metal in group 2, and sulfur is a non-metal in group 6. So I'm going to use my rules. I'm going to name the cation first. Mg is magnesium, and S is sulfur, but I have to add a new suffix. I have to drop the ending and add an IDE. So magnesium space sulfide. Let's take a look at the second example. CuCl2. Again, this is a metal. Cu is a metal. And to be more specific, it's a transition metal. And Cl is in group 7. It's a non-metal. So we can use the ionic compound rules to name this compound. Cu is a transition metal. So that means I have to use a Roman numeral to indicate its charge. For me to do that, I have to reverse the crisscross and figure out what cation and anion do I have. So I'm going to take a look at the subscripts. This 2 came from Cu. So that means Cu is 2 plus, and this invisible 1 came from chlorine. So Cl 1 minus. Remember that the cation, the plus ion, always comes first, the metal, and then the non-metal. Cu is copper, but because copper is a transition metal, I have to use a Roman numeral to indicate its charge. So it's copper 2 space. Instead of chlorine, it's chloride. So copper 2 chloride. The next example is Na2CO3. This looks a little bit different than what we were talking about, but let me go ahead and double check if I can still assign my positives and my negatives. So I'm going to reverse the crisscross and assign the charges. Now, CO3 is a unit that comes together. That is a polyatomic ion. It is called carbonate, and it looks like CO3, 2-. If I forget that, I can still use the formula to help me out. This 2 came from the CO3. And then there's an invisible 1 around the carbonate, and that came from sodium. And sodium is in group 1, and I know it's positive. If I crisscross the charges, I should get Na2CO3. Na is not a transition metal, so I'm going to use my rules. Name the cation first. Na is sodium. Space. And CO3 2- is carbonate. So this is sodium carbonate. Let's try another one. MgNO3 2. I want to make sure I understand how to assign my positives and negatives. Mg is in group 2, so it has a 2+ charge. But if I forget that, I can use the formula to help me remember that this 2 came from the magnesium. NO3, and the charge on NO3 is this invisible 1, and that comes from the polyatomic ions, so NO3-. Mg is not a transition metal, so I can just go ahead and say magnesium, space, and NO3 is called nitrate, so space nitrate. You should be able to go in both directions. If there's a formula, you should be able to give the name, and if there's a name, you should be able to give the formula. Let's do that example. Here in this example, I've given the name, and you have to come up with the formula. Calcium bromide. Ionic compounds depend on the charges, so I need to figure out the cations and the anions involved. Calcium is in group 2, so my charge would be 2+. And bromide is in group 7, so that would be a 1-. For me to come up with this formula, I'm going to have to crisscross the charges and make them as subscripts. So this would be CaBr2. Chromium fluoride. Now chromium, it actually says chromium 2 fluoride. So chromium is a transition metal, and the hint here is the Roman numeral. So I need to figure out the charge for chromium 2. The Roman numeral indicates that it's a 2+ charge. And fluoride is in group 7, so that's F-. I'm going to crisscross the charges, and I'm going to get CrF2. Barium sulfate. Barium is in group 2, so this would be Ba2+. Sulfate is a polyatomic ion that we have to remember. So the charge for that is SO4, 2-. I'm going to crisscross the charges, and I would get something like this, Ba2. SO4 is a unit that comes together, so I'm going to have to use parentheses so that I can show that 2 that comes underneath. Now, if I can reduce the subscripts that are outside of the parentheses, then I need to go ahead and do that. This 2 and this 2 can be reduced, so my final answer is BaSO4. I don't need to put parentheses around the SO4 because the subscript is an invisible 1. So I only use parentheses when the subscript is more than 1. Let's take a look at the next example. Calcium phosphate. Calcium is in group 2, so that's Ca2+. Phosphate is a polyatomic ion that we have to remember, and it's PO4, 3-. I'm going to crisscross the charges, bring them down as subscripts. So Ca3. PO4 is a unit that comes together, so I have to use parentheses and subscript 2. Good luck and keep practicing.